Hey! Today I would like to talk a little bit about the process of converting and using existing wavetable samples with Aleph. I'd always been interested in doing this due to the potential to expand the sonic possibilities of Aleph, but I really got interested in it after discovering the ROSC module in the Aleph code repository. ROSC seemed a bit more approachable than Waves, and the lookup table included in the ROSC directory was different than Waves, which led me to wonder how the tables were actually generated. After asking about this topic on the Lines forum, which is always very helpful, I was directed to wavetab.scd, which is a SuperCollider script that was used to generate the waves and ROSC tables. At this point, a big piece of the puzzle was already in place, as I now knew how the tables had been generated. But I still didn't know how to generate tables that Aleph could use based on samples. After looking around on the internet, I actually discovered WT-Tool, also created by CatFact. The purpose of this tool is converting wavetable samples to a format that could be used with SuperCollider. It seems that WT-Tool was mainly designed to be used with the Adventure Kid waveforms, and a link to the repository containing the samples was also provided. I was able to build WT-Tool, and, although there were a few things I needed to do to get it to run on my system, I was also eventually able to process the samples without running into any errors. While all of this was really great, I still didn't know how to interact with the samples in SuperCollider. After a bit more searching, I discovered this project, which basically solved that issue. While many great tools are contained in this script, the most helpful for me is the one that allows samples to be imported into SuperCollider, stored in a buffer, and played back. The fact that this project also used the Action Kid waveforms was an added bonus, as it seems to enable all subprocesses to be completed in SuperCollider. At about the same time, I also discovered the BiddyWave project, which is a wavetable synth for monome norns. BiddyWave also includes a set of wavetable samples that appear to be formatted for use with SuperCollider already. After trying several different methods of combining the code in the various SuperCollider scripts, I was able to establish a rough workflow for converting the BiddyWave and Action Kid samples to a format usable by Aleph, and next, I would like to examine the two SuperCollider scripts that I used to accomplish this. The first one is called Simple Buffer Utils, and it uses the code I found on GitHub. The main purpose of this script is to convert the samples into SuperCollider wavetables to test them and see what they sound like. I have tested it with both the Action Kid and BiddyWave samples, and, due to the current structure of the Aleph code, I resample them to 1024. I have a feeling 512 would also work if the Aleph module code was changed a bit though. The second one, called Convert for Aleph, actually converts the samples to Aleph format, and it is split into two parts. The first part makes use of the same code as Simple Buffer Utils from the SuperCollider script that I found on GitHub for loading and resampling. The second part uses the code from wavetab.scd for converting to Aleph format. Next, I would just like to run through Convert for Aleph to demonstrate how it works. First, we need to open the sound file. Next, we can check the file path to ensure it is correct. Then, we need to create a float array to hold it, and we need to actually read the data. Next, we need to close the file. At this point, you can check size if you would like. This is optional since, especially when working with BiddyWave samples, all the samples are 512. In order to use it with the current Aleph code settings, we need to resample to 1024. Next, we need to convert it to a signal. And we can check the size to make sure that our resample went correctly. At this point, I feel like it's important to mention that we don't want to convert it to a SuperCollider wavetable. It might seem counterintuitive, but we just need it as a signal going into the next part of the script. If we convert it to a wavetable, there's going to be all kinds of weirdness. Next, it seems to help to clear the post window in preparation for easy copy of the converted table values. Part 2 of the code comes from wavetab.scd, and it will convert our sample, our BiddyWave sample in this case, into a formatted lookup table that we can actually use with Aleph. So let's run it. We get a nice visual representation of the waveform on the scope, And more importantly, we also get the formatted table itself. You can select this very easily, copy it, and paste it into a file. So let's give that a try. So now we have our table values in a file. One thing that we're going to need to do to get this to work is jump to the end and remove this last comma. If you don't do that, you will get an error when you try to compile the program in C. At this point, we have our original BidiWave sample in a format that we can use with Aleph. So now that I've kind of talked about the process of finding and converting samples, I would like to talk a little bit about the module that I created based on RAWs to actually play them on Aleph. The module is called Table Voice. And I have already uploaded a copy to GitHub. I have not put the SuperCollider scripts in the module directory yet, but I will do soon. With regards to the code itself, basically, the first part is pretty standard. I'm including a local copy of osc.h because this is how RAWSC was set up, and it's a bit less involved than the version contained in the DSP directory. I took the code to include the table directly from RAWSC, and we have a constant frac32 wavetable that is 1024 with wavetabbing.c, which was what I called the file I made with the converted table from the SuperCollider post window. If you wanted to use a different sample, that would also be possible, and would just involve going through the same conversion process, and changing the file name after #include, or saving the converted file with the same file name. My original goal was actually creating several instances of the voice that I could interact with, and, although not fully successful, it did allow me to discover a new way of working with functions within the module process frame function. So we have our typical module process frame function, the same one that we always have, and within that I just added a call to a function I created called waveVoiceProcess. It takes the argument of the first and only voice, processes it, and sends it to the outs. This allowed me to get a better sense of how module process frame works, and also how I might be able to use that knowledge for more creative routing in the future. Wave process voice basically just contains the wavetable related code from the local version of osc.c, and this is what gets our wavetable playing. While I realize that there's a lot more room for improvement here, and also that it would probably be a good idea to actually get more familiar with the osc.h file included in the DSP directory to start adding more interesting functionality, like multiple voices, this module is a pretty fun wavetable monosynth, and it helped me to understand how wavetable synthesis works a bit better than before, and begin to start working to expand the sonic possibilities of Aleph. Finally, I would like to do a really short demo. Thank you.